Okay, you're set. Hello, what is up, everyone? So let's see. Yesterday we built the tokenizer, and today we'll continue with the parser, I guess. So we are done with this part, the tokenizer of the syntax analyzer, and we'll be building this parser today. So along with this parser, the syntax analyzer will output the XML code, which will be, I guess, input to this code generated later on. Let's see what we need to build a parser. Tokenizer, parser. So we already have the logic to output this kind of tokenized code. So we have the tokens and the corresponding token type. So now what do we need to do? According to this grammar, we need to create a structure like this, a parse tree. So this should be the final output of the parser, or tree structure, or hierarchical structure like this, which is again the XML code. Okay, we need to write this kind of modules: compile statements, compile if statement, compile while statement, and so on. Okay, let's skip this. While statement. Hey SC, what's up, man? I'm good. What about you? So what's up with COVID in your area? Is it that much bad? By the way, in which state do you live? Are you from Kerala? Oh, but okay, from Chennai. Okay, but are you and your family safe? Yeah, same here. I don't really go outside that much. In fact, To be very honest, I don't go outside at all unless there is something to do. Where I'm from, Gujarat, so it is bad over here as well. And the native place from where I'm from, my village, there the situation is much worse, because like every day each at least one person is dying because of COVID. So it's really bad for the rural areas. But it's all right for us, because I live in a live in an area which is not that much crowded, and we don't really go out that much, so it's all right for now at least. Yeah, right. So you must be working from home only, right? Or is it, do you have to go outside to the office or what? Well, it is, so I have completed the part one of the course, and I think almost halfway through the part two. Right now building a compiler, and after that I will be building the operating system. Not, it will be not that much complicated, like not the whole operating system, but just the basic parts of it. So that will be it for this course, and I'll be looking for something interesting afterwards. What about you? Did you complete your project that you were working on, the web app? Oh, for the past 4 months. So what is taking much time, the front end part or the back end part? Client's business logic. Oh, so does it involve? I think for the CRUD apps, I think mostly the complexity lies in fetching the data, right? Database fetching and all that. What are you using, by the way? Yeah, you are using SQL, right? For the backend. So is that yeah. So what kind of business logic is there? Like, what is taking so much of time? So you mean when you have to refactor the code, right? All right. So that also means that you have to refactor the models as well, right? The database models. Yeah. So actually, I have never worked with SQL, but for MongoDB, I think it is flexible. Like you can change the model on the fly and without much complexity. But I can't imagine what it is like for SQL database. Yeah, it's not relational. That's why. So you can change the model on the fly, and even the previous data can work with the new model. It's just that much flexible. It is document based, I guess. But anyway, I have not worked with even MongoDB since, I don't know, maybe 1 or 2 years, maybe. I really like the NoSQL databases, I think. Yeah, sure, it's alright. I'm just here for the fun, man, so it doesn't matter. Yeah, alright. Check grammar expressions. Parsers design a set of compile-x methods structured according to the grammar rule. Each method should output some of the parse tree. The parsing logic of each method follows the right hand side of the rule. Okay. Okay, this should be the final output in XML format. Check grammar, check analyzer. The parser generates the output terminal element. Okay. We'll check it out later. We have already taken care of this part, the tokenizer. So now we need to build the compilation engine. Let's create the compilation engine file. To call it compilation engine. Should I call it compilation engine or parser? Well, let's just call it compilation engine, doesn't matter. Compilation engine dot py. Oh, what the? check analyzer file, check tokenizer. Oops, this should be inside the check compiler directory. Compilation and okay, that is correct now. Okay, here we have a class named Compilation Engine. Definition. Let's see what we should pass to the init method of the compilation engine. We should probably check out the API. This is the API for the tokenizer. Alright. Compilation engine, the constructor code gets its input from a tokenizer and emits its out. So should we take the XML file as the input for this from the tokenizer? Should we take the output directly? Let's see, gets its input from tokenizer and emits its output. But in what form should it take the input from the tokenizer? Should it take the text directly, or the output is generated by a series of compilers? Okay, so let's see. Each compilex routine is responsible for handling all the tokens that make up X. Okay, so I think we might need to change the tokenizer logic. Let me check. Okay, so we were supposed to print the tokens and store it in a file in a separate test program. So let's see what can we do to change that. This is the tokenizer. As it is now, what we are really doing is we are just storing the So this advanced method as it is now, it is just going through the whole file and storing the tokens in a. Okay, so that was not exactly, I think, what we needed. Let me check the API of tokenizer again. 117. Advanced gets the next token from the input and makes it the current token. This method should be called only if it has more tokens is true. Initially there is no current token. Okay. So what we were supposed to do is that this method advance should only return a one token per call. What we are doing is exactly different. So I think we might need to refactor the code. What should we really do with it? Okay, now comes another problem. So we change this token type. So that might be a problem because we might need to use this token type for the parser as well. Let me check. Yeah, I think we might need the type here in this functions. Okay, what should we do now? Are there more tokens in the input? Okay, what's up with the basic version and complete version? So do we have to build this compilation engine in 2 stages also? Let's worry about it later. Implement the tokenizer API described earlier. Okay. So the basic version should handle the input without the expressions, and the complete version should include the expressions as well. Okay. Okay, what should we do with this function now? What we are really doing right now is passing each and every line, and in that also passing each and every syntax, and extracting the tokens and printing those tokens in a file. What we really should be doing in this function is we should be returning a token only when we call this advance. In the context of this project, parsing is defined narrowly. Narrowly is the act of going over the tokenized input and rendering it. Okay. That handles any jack code except for expression. Right, but what after that? So this compilation engine module should take input from the tokenizer. It should output the XML file. Okay, the next routine must be compile class. Okay, so the first token is supposed to be class. And this module in turn might call this modules, and these modules might call other modules or itself recursively until we are at the end of the file, or until we reach the last token. Okay, so the individual compile methods doesn't matter what we write there right now. Compile class, how should we do it? Let's check the compilation process in detail. This might give us some idea how to implement it. So this, it should call this kind of methods recursively. Let's go to the starting of this process. This must be the input. Right. Let's assume that we read y, so we know that we have to call the method. So we encounter this symbol, we just need to print it like this. But we already have this kind of tags for this individual tokens, right? Let's read on. Once we arrive at this, so this is an expression. Wait, but how do we know we have arrived at an expression? So it is based on this grammar. Okay. So when we do the parsing process, do we have to read the source code file or the tokens directly? Let me see. For the term, we have variable name and constant. So this is a variable name, we'll directly print it. We'll end this method and we'll go back to compile expression. No. Yeah. So the next term is either it is supposed to be op term or nothing. So in this case it is op term because we have a operator and another term. So we'll print the symbol, the operator, and after that I think we'll print the next term, which is this 100 constant. Okay, for that we need to call compile term again. So this is just like reading the individual tokens. So yeah, so we don't need to read the file, we can just read the tokens. And what they are suggesting is when we call this advanced method, it should return the tokens one by one. But that's not what we are doing currently. We're just passing the whole file and writing all of the tokens to a file in a one go. Okay, let me try to refactor this code. Can we do to get only one token at a time? You probably need to write this logic in a different method other than this advance. So right now I can think of only one thing. So whenever we are writing this, whenever we are doing the writing to a file, what we really should be doing is returning that token, but only when we call the advanced method. So I think what if we write this line logic, the fetching of the code lines in a different module altogether? So it should only return one line at a time. And this other logic which is going through each character of the line should be in a different module altogether. And this, it should stop this passing of each character when we come across a token, and it should stop at that point. I can't think of any good implementation strategy right now. I think we should save this file as it is right now, because I don't want to mess it up. Okay, we might need to use git version control, I think. Okay, let's do git init. Should we add all of it? Yeah, let's add all of it. What have we done till now? Tokenizer version, individual version. Okay, so now I think we need to create a new branch, and work on the new code. So can we do that? I don't really know how to use Git properly, so I might have to Google it up. How to create a new branch to work on refactoring code. Yeah, maybe this is what we need. New git branch. We just started using it for our production. We are running into a slight issue. We need to figure out how to handle general code improvements. It appears that you are trying to avoid merging the developer branch back into the feature branch. It is beneficial to avoid the steps, but sometimes it is necessary. A technique that we are starting to use also is a rebase onto. Instead of merging the developer branch into the feature branch can move to the end of the developer branch in order to apply the feature. Oh, I don't really get it. Okay, in Git and most other VCS tools, branching is one of the main constructs that really make it useful. These branches are almost like a new copy. Whenever you need to create a new feature, fix a bug, or rewrite any of your code, it's a good idea to create a new branch so that none of the changes of the master version. This is important since it can be very difficult to debug code changes from memory, especially in check out this B branch name this. Okay, so I use this hash creating a branch from a tag. Okay, let's just use the generic branch method. We'll create a new branch. What about this though? What are they really doing? Checking out in the feature, then they are creating a new branch version 2. Rebase onto develop push your origin version 2. What is inside this pikesh? Let's create a new branch. Call it tokenizer version 2. Okay, so we have switched to a new branch. Let's check the status. Okay, let's work on this branch now. Do I need to close off all of this? Okay, now let's open it up. Now that we are in the tokenizer branch, we should open up the program. Check analyzer. Check tokenizer. Okay. So let's try to refactor the code now. Okay, let's start. Well, if we were to stop at a token, we need to keep track of the index of the character as well, because that's what we are really doing here. Just stopping this loop is easy because we can just call the what was it, file next line or something on the file method. But how can we stop this character passing? We need to create our own logic of stopping these characters. What the hell with it? Let's not use this API. Make it so that the compilation engine takes the output of this file, this tokenizer file directly. It will be easier because I can't think of a solution right now, really. Okay, so I think I need to clear the branch. Merge branch into master branch. Okay. Although we have not really done anything, I need to get rid of the branch. Remove a branch. Good. Good. Good status. Oops. Well, I did not really modify it. Okay, it doesn't matter. It's just a swap file. Okay, so we'll change the API as per our need. For this compilation engine, the constructor should take the output of the tokenizer. This is the tokenizer file, tokenized file as the input. T file, let's just call it T file, tokenized file, self dot T file equal to T file. Okay. Get tokens. Get token. So this method will read the file and get the next token. So what should it do initially? Let me check the file method. Read files, read line. I think it was read line. Yeah, it is read line. But initially the file consists of the tokens tag, so we don't need that. What we can do is, well, this is right logic over here. Token is equal to self dot t file dot read line if token equal to, right? I think first we need to trim it as well, so we will call dot trim afterwards. Is it trim or strip? I think it was strip. Yeah, trim is in JavaScript, so we should use strip. This will strip the space after on the left and right side. Now check if the token is this tokens or token equal to this. Oops. Okay, in this case, what should we do? We should get the next token. So token is equal to strip. Now let's see. We'll return this token, right? Yeah, so this is where it gets complicated and it starts falling down, because we will need the token type as well. So that's the reason why we created the tokenizer. And if we just return this token, now it kind of defeats the purpose of the tokenizer. You might as well have done all the logic here. God. This is messed up. Read characters from a string. Python. Okay, this might be a good idea. In this advanced method, we can read all the tokens in a one go and not write it in a file. We can store it inside in a list. This might be a good idea. We can store it in a list, and this advanced method should return the elements of this list one by one. Yeah, this might be a good workaround, I think. Let's use this method. Okay, but before that, let me save this thing. to get rid of this. We'll create a new branch, tokenizer 2 again. Okay, so now let's open up, check tokenizer and compilation engine as well. So what we can do is let's create a new list, self dot tokens. So this will be an array. What this function should do is wait. I think I did not commit. Should have committed before changing anything, right? I did not change anything, so it's alright. So now we can create a new branch. And we can start working on it. Okay, let's edit this. Instead of writing to a file, we'll add the token to the okay, so let's delete up to this point. Let's delete this as well. So we need to append all of this to this tokens. So yeah, we'll do self dot tokens dot append. Let me check. Append list. Yeah, it was append, right? We'll append this. We'll do it over here as well. And here. So now let's change the name of this function from advanced to, what should we call it? Pass all tokens. Yeah. And we will call this function directly in the init. Self dot pass all tokens. Right? So at the end of it we have the tokens filled. Now we can write the logic for the advanced method. It will be simple now. What we really need to do now is so we need a self dot current token index. It will be 0 initially, I guess. Let's keep it as -1 initial. We'll do self whenever we call this advanced method. First we will check if first we'll increment it, so we'll do self dot current index equal to self dot current index plus 1, and after that we'll check if self dot current index is less than self dot, okay, how can we get the length of this list? Using this length. Okay. Or we could use this pop method as well. Yeah, but no, it will return the last inserted value. Let's just use this. So we'll check if this len self dot tokens will do return self dot tokens and return self dot current index. Yeah, this is what we'll do. So when we call it for the first time, the index will be 0, right, the first token, and call it second time it will be 1. So if there are only 3 tokens, suppose we have only 2 tokens, then 0, so it will return the first one. When we come here second time, the self.current index will be 1, which is less than tokens, so it will be, and afterwards it will be 2, which is not less than length of tokens. Yeah, but we need to skip this part as well, the tokens. We don't need to skip it because we are not reading from the file, we are reading the tokens, so we don't need to skip it. Okay, awesome. Okay, so this might work. This will give us the next tokens. So we have a method which is a hacky method according to the API. Wait, but in this case, should we return the whole token in this XML format, or should we just return the value when we call this advance? Mm. Okay, I think I'm going to continue building this after the lunch. So I'm gonna take a lunch break right now. I'll be online afterwards, so I'll see you guys after the lunch. Bye bye.